Happy to see you, first of all. Maybe you who are very much interested in learning more about data, spatial data. I'm also happy to see a lot of young women there. As you saw, 15 years in the game, and we've not had as many women as I'm seeing here today. So I'm hoping that as you start this journey, this is something that you continue with. So I'll be taking you through this session just to show you on how you can conduct spatial temporal analysis using a tool from company account. So first of all, how many of you have come across S3 or ArcGIS? Africa Geospatial. Few are high, but it's okay, that's why I'm here. So I'll be just doing a quick introduction on Africa Geospatial, then we just focus the session spatial temporal analysis. I hope to make this as interactive as possible. Hopefully we'll stay hard and so this session I try for the rest of the week, and I also look forward to interacting with the rest of the week. What's going on? So let's start with Africa Geospatial. So Esri is a company that creates software for not only digital marketing, but also supporting location intelligence. An example of location intelligence is if any of you are using an app to request for a service like a vehicle, or you're using an app for a delivery and so on. There are many layers of information that are being used. Let's use an example to requesting taxi. So I'm standing here and I'm requesting taxi. So within this system which we are using, there's information about the passenger, there's information about the driver. So the first level of location will be first and last driver. Then they highlight like, okay, we have 5 drivers within particular distance, let's say 1 kilometer. Then the second level, where a lot of these applications apply additional intelligence rates. Of the 5 drivers who are within, let's say 1 kilometer, how many of them have been working for the longest time and did not pay as much money? So that's really the person being given the priority in terms of being able to pick you and drop you. So that's the issue. The X-ray, the company has been there for 50 years. I work for the Middle East and Africa office, based in Dubai, but we cover 72 countries. Africa, the Middle East, France, as well as Central Asia and Pacific. So, as a company, one thing we notice is that for Africa, we have limitations in terms of access to data and capacity. So what the company did is we launched a program 5 years ago, targeting young professionals who are interested in building capacity to be able to work with geospatial data and come up with solutions for their mobility. So this is a program called the Geospatial program, and for Africa context, we have agriculture. So with the Geospatial, we have access to data, we have access to tools. These are mapping and analysis tools, which will also allow you to create web maps for them. And then we have access to value resources. So we have a huge team that works together with industry experts and with education institutions to come up with tutorials that you follow at your own pace and be able to build capacity in the people. I think one of our main flagship organizations that we have across Africa that's been able to leverage this. It's a group that has been involved in mapping flood-related risks across Nigeria. This is the Geohazard Risk Management Initiative, led by one of our champions in the region, and they've been able to work with a few local government authorities to come up with plans. That's back to you. So with the GeoPortal, the reason I wanted to start at this point is that to let you know that you can create an account on the GeoPortal. It's a free account. To do that, for those who don't have an account, if you choose the sign-in option, you just come to create Africa GeoPortal account, which is not so clear, but there's a link here for creating an account, and you can create an account either using your social media login or just by email address. To get to the site, by the way, it's just africageoportal.com. You can go to Google and search for Africa GeoPortal with the letter to this page. Then when you go to the top phone number there, that's where you're able to put the account. So what you get in an account once you create so some of the things you're able to get is the ability to create maps. So at the top, so they create your maps, and you can also create 3D maps, because you notice that when you're working with maps, you want to look at 2 dimensions, but you can also add the 3rd dimension, which is something we discussed on data. In our case, is the time. But at times, if you have data that has elevation information, you can use our 3D scene to visualize this information. Also, from the account, you have access to access notebooks. So this has just been built on top of Jupyter notebooks, and you can have your own notebooks there. You're able to run them, bring in data from elsewhere, and be able to do the spatial analysis using the tool powered through that. Then you'll be able to post your own content. If you want to upload your geospatial data, shape files, imagery, and so on, you're able to upload that and manage that. So own private data, we do not get involved in trying to produce your data. And then now, you also have access to a desktop application that are this desktop application is called Access Pro, which is a very powerful desktop application for working with spatial data. So for many people, accessing this application has been a bit of challenge, especially people who are just from university. But for users on agriculture portal, you should be able to access this license and be able to make use of it solely for the purposes of learning, to build capacity and for not anybody. So for the licenses, if you come to your account, you'll be able to see your settings information. And from that point, we have Access Pro. And with Pro next to it, you're able to download the software or the application, install it on your device, and you can start making use of it. So this is something that for anyone who'd like to start access it and start making use of it, please download and install it. And we have for the rest of the week, if you have any issues, please let me know. But I'll also share out my contact details in case you need to follow up on something. We can also have a discussion around it. We just presentation. So for spatial temporal analysis. We are going to look at this in three main sections, then I'll share with you resources that you can use later on. So first we go into the concepts of space-time analytics. So for space, when you say location, you mean X and Y or coordinate values. But you have this additional aspect that is now being supported. You've collected data over time. How do you first visualize it? How do you look at it on a map? And secondly, how do you apply analysis on it? So we go into that. Then we look at the tools we have within ArcGIS. That's again that support space-time analysis. Then we'll do a bit of space-time analytics, do a session recap, and then I'll share resources. So within ArcGIS, as I mentioned, now you have access to the desktop application ArcGIS Pro, and you'll be able to perform this analysis. So normally our software is available at different license levels. The one you have will allow you to perform this analysis because we're using infused capabilities to be able to do the analysis. One thing about the tools that you have in ArcGIS, a number of them have deep learning capabilities embedded in them. So instead of you trying to figure out how do you bring in these capabilities using libraries that you built or open libraries, we really have tools that. Then we look at the specific tools that support this, and yeah. So when we look at the concepts, let's start with what is a space-time cube. So a space-time cube is a data format that we use to work with location data that has a time field and be able to use it for analysis. So normally, if you have any geographic information, it will have the X and Y coordinate values. So you're able to map something that is where it is based on its geographic location. However, over time, what you've noticed is that now you can handle data, adding a time element or Z. So with time, it means that other than information just falling flat within its location, now we're saying this information takes place at different times, and how does that, or what does that tell us about the trend? And how can we use this information to focus what is going to happen in the future? So that helps us a lot in that. So once we have that time element, we're able to create cubes. So from each cube, they have a specific measurement for each cube. In this case, it's 10 meter by 10 meter. And then when we look at the height, we're looking at different time stamps. So we have, in this case, it's showing us the month of January all the way till July. And we're able to visualize that. We're using cubes to look at this information. Hence, space-time. So within the space-time cube, the first thing is we have a bin. So one bin contains information on what are the X and the Y coordinate values, as well as any statistics tied to that particular cube. So this would be the sum of a particular event, maybe movement, and so on. That's being captured there. Then for each line here, we have the time element that is being captured. Sorry, you have the location element that is being captured there. Then you have a time slice for each level. So each level here will represent a different time interval or instance. So some of the summary you can make using space-time cubes are you can sum up information together, you can come up with the average, the most likely occurring number of events. minimum, maximum values, as well as standard deviation. So all of those are different ways you can summarize this information, depending on the kind of analysis you're doing. So once you have that information, you're able to perform trend analysis. And we have tools ready just for you to run and get this output. But then again, if you want to have your own custom definitions of parameters, you can use Access notebooks just further. So how do we create a space-time cube? Some of the things that you need, first of all, your data needs to have a time element. So not all data has time field, and most of the time when you're looking for data, just verify wherever you're sourcing the data, it has that time field, and the time field is stored as a date field. That's the only way that's going to. But it can also support different time fields, let's say to a continuous event within a day and so on. You can have your start and end time and so on. The other thing that's necessary is that you need to have the projection of your data into a local context. So whenever you have geographic information, it's either being visualized and analyzed either in a global context or a regional context like Africa, or we're going to look at a smaller area. So this could be something at the level of state or local government authority, so on. So you need to make sure it's projected correctly. Then for your data sets, at least there needs to be 60 rows, and of the 60 rows, at least you need to have different time intervals. So this would be daily, weekly, monthly, annually, whichever way you want to look at this data. Once you have the time field and your data is ready, then you have different ways of being able to create a space-time cube. The first way is if you had different points, you can run a tool that aggregates this information together to create a cube. Alternatively, you can use defined locations to be able to create your cube. So for example, it was collecting information on all AGAs, LGAs within Lagos, then I would map them to the different local government authorities and be able to do my space-time cube based on that. So we're using an existing extent or area to map this information and be able to create the space-time cube. In the first one, warrant time location, we're just seeing each point has an X and Y value and so on. Then the final option, if you have information like weather data, climate, any climate information, temperature, so on, you have it in a format that we call a multi-dimensional raster. So for raster, it's data format for working with imagery or continuous information. So in this case, you can run the tool specifically for using your multi-dimensional raster layer and be able to create your space-time cube from that. Whatever the case, the output will still look very similar in that. So we have each bin recording information, then we have each long line tied to a particular location, and finally, time slices for different periods. So after you create the cube, one of the first things you want to do is visualize this information in two-dimensional. You might want to look at it in three-dimensional aspect, and you might want to push it forward to a web application. So one thing with ArcGIS, we provide that seamless process of creating data on an application, then pushing it forward as a service on a web map. And when it's on a web map, it means anyone can access this information on a browser, on a mobile application. So what are some of the analysis that you can do with space Thank you. So the first thing is you're able to visualize data, you're able to perform time series clusters, in that you find that whenever you have data that's being mapped and so on, there's some things you can obviously see based on how it has mapped. However, there's some relationships that they're not obvious to the eye. That's why we're relying on the tools to pick up that information. So there'll be relationships that you will not see immediately, and we're using the tools, as I mentioned, that have deep learning capabilities produced in them, and we're looking at the data or the attribute information for each point to be able to tell us what's the relationship of that is there, but criteria cannot see. Then you're also able to identify outliers in your analysis. Again, if you have a lot of data, let's say 80,000 points, you can see some things that sometimes, honestly, it is technology to help you. So you can run your outlier analysis and be able to pick out which of these events or occurrences are not ordinary or out of. Then you're able to identify emerging hotspots. And this is one of the best capabilities that we have. Because sometimes, again, because of the temporal aspect, you might not really know what is going on in the sense of, based on the trend, is the situation improving, is it getting worse, and so on. As I said, you have a lot of data, you're looking at different aspects and so on. So how is this being captured or analyzed? So we use emerging hotspot analysis to tell us where do we have a case intensifying, or where is it actually going down, or where is it that there's no effect, like there's no change in temperature and so on. And everything is just running as it's needed. So you're able to do that. Forecasting is the next thing, meaning that you want to project. You want to know, if I have information over the last 10 years, then how will the situation be for the next year, 3 years, 5 years, and so on. So we have tools that support that. An example where this has been used is one of the data sets that we have made publicly to people. There's a climate prediction model that is able to predict over the next 50 years, and actually up to 2050, then 2100, what will be the effect of climate if one mitigation measures are not applied at all. That is, we're going to understand the trend. If mitigation is applied, so which places will we likely see that, okay, there's a bit of a change, and if extreme measures are applied, like literally people stop driving cars or moving around, and we just say, like, okay, we're going to addressing climate issues. So able to predict all of that, and it's using tools like this that have supported that analysis. Just looking at some of the tools, we have the outlier analysis, and the main purpose of the tool is to first help you identify of the entire distribution of your data, where are the relationships, and where do we find that is an outlier, like an extraordinary event out of this situation. So for example, if I was looking at crime data, which is a data set we're exploring today, and we have reports being done over 50 years, so where would we say that there's an outlier, or where would we say that maybe there's a relationship? In the sense that this information is not together. However, we can see the trends and the behavior. So from outlier analysis, we're able to identify places where we have high clusters, identify outliers as well as low clusters of information. The other one is time series clusters or clustering, whereby we're looking at cases that have similarities, as I mentioned, and it will just give the information based on their behavior. So you see that we have new clusters spread out, which probably would not have become obvious as the inner trends. So it helps you to put together information that behaves the same, even though it's partially distributed. And the thing that's really helping you to do this is the time element, saying that this thing is the right thing, located separately, but because of how the trend has been over time, they actually have the same behavior. Emerging hotspot analysis, as I mentioned, we're looking at the trends of information, whereby we'll be able to pick out clusters, but we'll be able to pick out hotspots based on time. And it gives you 17 different kinds of outputs, which once you run the tool, then you'll be able to see on your map areas where there's sporadic hotspots, areas where before it was a hotspot and now it's a hotspot, meaning the situation is changing or reducing. Areas where from the beginning of time till now, based on the data I have, it is a hotspot, it has always been a hotspot, it will never stop being a hotspot. Areas where we have new emerging hotspots. So you find if I have a data set of 20 years, then in the last 3 years, it's telling me that for the 17 years, this point has never had an issue, but all of a sudden is up here. So that's a new hotspot. So all of those things are available, or different ways of visualizing this information. And as I mentioned, also you can do your time series forecasting. So if you have your data, in this case, you'll be able to have the data. So that's the blue. Then you'll be able to train this data. So I'm sure by now all of you are very familiar with the aspect of training. So you're telling that this is my data set and dear system, requesting for asking you to have a look at the data, see how it is behaving there, be able to predict the next instance in time. So in this case, if I have different months, I can be able to predict the next month, so on. So it is accurate as the information is there. Meaning that if I have January to June, I'm likely to have an accurate prediction for August. But if I push it forward to the next January, it might not be as accurate. I may need information for a subsequent month to have more accurate prediction of the future. So now I'll be walking you through some of the steps that you can use to first create your space-time cube, visualize this in 2D and 3D, evaluate emerging hotspots, and finally perform your forecasting. I'm really hoping that we'll be able to do that. I'm not sure about this resolution, but I believe that the session is being recorded, so people will have access to clear information. So before we go into the actual analysis, I'm just asking, or many of you who interact with data, where do you, like, what are some of the portals that you use to access data? Okay, another example, please.
Okay, please. Okay, please. Okay, please. Okay, please.
Any other example? Okay, I've had GPT. So I believe right now there are many sources that you're using. In my case, what I used was, for the purpose of this session, I searched for data from Kaggle, and I was just exploring like what data is available that has location information that's available on Kaggle. And the data sets that I was able to find for the purpose of this session was on crime trends in West Africa from 1970 till 2020. So that's a very good data set because it ranges over a long period. Fortunately, the information had a column on different cities, which is what I used to mark the information. It's covering different countries in West Africa. It is focused on Nigeria, and then we have a field on cities, and that's what I used to mark the information. So you remember I had indicated that different ways of creating a space-time cube. You can use location XY, you can use regions. And now beyond space-time, there's a way you can mark information and we call it using geocoding addresses. So it's just saying that if I see this city within this region, try then maps that information based on that. Let me just launch that's one. So Pro is it's a very powerful tool. It has gone through several iterations of development and access. So the latest one is Access Pro, but previously we used to have versions like ArcInfo, ArcView, ArcMap, and so on. So Pro is the latest one, very good in terms of performance and being able to support different kinds of work. So in the case of the data I mentioned, you have the crime information. I just filtered for Nigeria and you have the points there. So one of the first things that you can do once you get your data within ArcGIS that you can do with any other application is perform a bit of data engineering. So we have these capabilities just for you to explore the data, look at, okay, what fields are there missing values, are there outliers, and so on, based on the attribute information or descriptive information about the data. So you can do that. And what I did on my side was to create a heat map or a heat calendar map on the data that's there. So this is projecting information. We have the months, and then we have the day of the month, so on. And the values in the middle, they just have different shades, whereby you have light shades indicating that the number of reports time are fewer, but where we have dark colors, it means that the number of reported times are many. So I don't know what to be the relationship there, but maybe you can help me in describing some of these things. So like in January, on January 7th, it's showing that, and this is looking at the entire data set, and not something like that. So from 1970 until 2020, on January 7th, across that entire data set, there have been crimes reported 25 times. So these crimes are focusing on violence tied to militant groups. And normally you find that some of these crimes are tied to events. They are tied to babies, things, and so on. So I'm just checking if there's anything of significance that takes place January 2nd by any time. On February 9th, it's not in which year, it's just looking at the entire data set. So this is just the data. the data as it was recorded. It's saying that over all those years, the dark blue here, there have been 25 times over all those years where people have reported there was violence tied to relations. So there, what about on May 20th? Because that's the one that had the highest number of anything that happens on May 20th. So we are looking at from 1970 up till 2020. On May 20th, we've had had 34 times where violence has been reported. Okay, let's hope that there will be something. But normally you find if there's no actual thing, then it means that
is there some kind of drill-through feature? Like,
Sure.
you know, 1970 decades, 4 decades. So you can drill through this location and some nuances.
it's a very interesting. Let me just change this to. So because the screen is putting that base map to help us explore this information. So I'll just zoom out. So we can see all of Nigeria. Then, so I've selected May 20. I don't know if you can see that there are some points that, so it's very distributed. Yeah. And then let's add another context. I'm going to open chart on the different. You really zoom in.
Yeah, are we good?
So if we look at
In
to the table, the one. So some of the ones that are highlighted, the perpetrator group, the biggest one was as the data was collected, was Afghan extremists. Then the second chunk was Afghan extremists is 47 and 14, which is the biggest. Then you have Boko Haram. Then there's 28. So as you can see, first of all, it was 1 May 20, distributed all over Nigeria. So if there's no specific event, it means
all right, I want to get clarity on something. This report is actually talking about the things or the crimes we may reported. So I want to know on what if you can get more clarity if that particular date were the dates the crimes they committed. Because the crimes that are committed today and can be reported 1 month after or 1 week after. And most crimes are not even being reported yet. And some persons can falsify reports just to blacklist the particular tribe or something.
Mhm.
And that's the beauty of what's happening to data. Yeah. So let me open something else I used for context just to. So what's showing that?
Okay, are we good? Or should we?
Yes, finally it's content. So there's an authoritative source of since I've lost my connection to
We are still
My name is Bootcamp. Thank you for the session. I want to ask how I'm coming from the viewpoint of nature education. How can it enhance data acquisition? Right? Real-time information. If kind of what we do in lecture, how can it be implemented? It can be implemented in systems where when data is connected, it needs to be. And then you all do quantitative data. How can this work? Thank you for your question. The request that you provide more context in terms of quantitative. MIE. It's more, it could be total needs, it could be AI, so it's more in different areas based on whatever development. So how could we improve spatial analysis? So an example of quantitative information that it could be the discussions with the interviewers, so the discussion it could be time, it could be dates, it could be location, it could just be statements. Okay, thank you. So let me try to answer that. First of all, let me mention that yes, we do support other than working with data that's been historically collected. If you have an ongoing active exercise of collecting information, we do support real-time and near real-time analytics to be able to, as the information is streaming in, we're able to get this information. And that's usually powered by the step I mentioned where we have it on the web as an application. So because this is a service that is actively interacting with people and so on, as the information is captured immediately, it just reflects with the service and you're able to visualize it. So we have seen this supporting different activities. An example being for a lot of non-profit organizations, they use our applications to support this. So not only on the aspect of the data being collected, but the behavior of the person collecting the data. So we can see normally this person